Let me get your attention. Let's get going on this, I suppose. Find the value of f of g prime at the given value of x, so the composition of two functions. And so really, the problem you're asked to solve is f of x. With this example right here is if f of u is u to the third plus 1, and the inside function is square root of x, the actual problem is square root of x to the third plus 1. So you asked to find the derivative of that at 4. So we're going to find df du. That's the outside function, which is going to be 3u squared. So the third power we could consider the outside function. And then du dx, which is g, so taking derivative of u is the same as taking g. That's equal to 1/2 x to the negative 1/2, which is 1 over 2 square root of x. So there's the derivative of the outside function, derivative of the inside function, and we're evaluating this when x is equal to 4. So square root of 4 is 2. We end up with 2 times 2, 1/4. Well, that's really the derivative of the inside, and then we would plug that into the derivative of the outside. So we have 3/16 is the answer. So you work outside in on the derivative, and then you work inside out on the value. What happens if you can write a function as a composite in different ways to get the exact same function? Do you get the same derivative each time? The chain rule says you should. Try it with the functions exercise 39 and 40. So it says find the derivative if y is this function right here, sine of x squared plus 1. So now they're saying the outside function is sine of u plus 1, and u is x squared. So if I put that in for u, I would get sine of x squared plus 1. So there's their composition of functions to get the original. So on letter A, dy du, the derivative with respect to u, would be cosine of u plus 1. There's the derivative of what would be the outside function. Then the derivative of the inside function, du dx, is 2x. Now, we're supposed to, we'll get the derivative if we multiply these two together, because when you multiply those two together, the du's cancel and you get dy dx. So we have 2x cosine of, but u is x squared, so x squared plus 1. So there's the derivative. Now, we knew that was going to be the derivative. It's the derivative of the outside times the derivative of the inside, which is 2x. We knew that. But the point of this is saying that now we can say, well, no, the outside function is sine of u, and if we plug in x squared plus 1, we get the same thing. Now, if we take the derivative and with the same process, we should get the same answer. So dy du on this one is cosine of u. Du dx is 2x, because the derivative of 1 is 0. Well, now we get 2x cosine, but the u is different this time. The u is x squared plus 1. Cosine of x squared plus 1. And we find out that we get the exact same answer, but we have two different composite functions to get the same original one. So this is all about notation, really, and how you can get the derivative. So 39, you'll have to do something similar to that. Use this as a model to do number 39. Students will be able to find derivative using the chain rule. Exercise 25 to 28. Find dr d theta. I guess in these two right here. Try that first one. This one should be fairly straightforward. Dr d theta is -3 cosecant squared of 3 theta minus 1. So the derivative of the outside is cosecant, negative cosecant squared. Derivative of the inside is 3. Hope you don't mind that I put the 3 out there right away. I knew I was going to multiply by 3. Oh, I think I'll do this one for you, or with you. So dr d theta on this one, this is equal to theta cosine theta to the 1/2. So the outside is 1/2 theta cosine of theta to the negative 1/2. There's the derivative of the outside. That's always the derivative of square root, are those 1/2s. But then multiply times the derivative of the inside. And the inside is the product of two functions. So first times the derivative of the second. So negative theta sine theta. That's the first times the derivative of the second. Derivative of cosine is negative sine. And then plus the second, and then the derivative of the first is times 1. I mean, you don't have to write times 1, but I'll put it there to show you I did the product rule there. All right, that's quite the mess. On top is this is going to be the top right there. Negative theta sine of theta plus cosine over, the 2's already in the denominator. That's to a negative power, so square root of theta cosine theta. So there's the derivative of that one. Give that next, if there's no questions on that one, try find the second derivative of this function right here. The derivative cotangent is negative cosecant squared. Oh, maybe the x over 4 is, we haven't really looked at that one yet. But it's 1/4 x, 1/4 x. So the derivative of x over 4 is just 1/4, by the way. We have negative 8 cosecant squared of x over 4, and then times the derivative of the inside is just 1/4. The first derivative is negative 2 cosecant squared of x over 4. All right, now try to get that derivative, and maybe you had it right anyway. See if you can go from there if you had it wrong. What do you think the outermost function of this one is? The outside function. Any ideas?
One half cosecant squared, cotangent squared?
No. That's the outside function? Are you telling me the derivative?
Yeah.
Okay, what's the outside function?
Negative 2 cosecant squared.
No. Too much. Nobody knows what the outside function is? What's the outermost? Squared, right? The squared, yeah. So the squared is the outermost. So let's take care of the squared. We'll have negative 4 cosecant, reduce the power by 1 is 1, and then x over 4. So there's the outermost function. Took the derivative, multiplied times 2, reduced the power by 1. So what's the next function? cosecant's the next function. So then we got to multiply by, and I'm going to ignore the square because we already did that piece. So negative cosecant x over 4, cotangent of x over 4. That's the derivative of cosecant. And then the last function on this is the x over 4. And the derivative of 1/4 x is 1/4. So that's the derivative. We can clean this up a little bit. 1/4 of 4 is 1. Negative times a negative is a positive. So cosecant squared of x over 4, cotangent of x over 4. There it is. It cleaned up rather nicely, I think. Questions on that? That's a rough one. That's 3 nested functions there. All right, AP loves general functions. It removes any kind of actual function. And the question is, do you know the process to find derivatives? And so let's go through this. A, the derivative, I should read it. I know what it was, but you probably don't. Suppose that functions f and g and their derivatives have the following values at x equals 2 and x equals 3. So here's values of f of 2, g of 2, f prime of 2, and so on, and f of 3, g of 3. Evaluate the derivatives with respect to x of the following combinations at the given values of x. So letter A, we're supposed to take the derivative of 2f. Well, that's just 2 times f prime of x. I'm not going to do product rule when it's just a 2. If it's another function, yeah, like letter C, definitely product rule. And we're evaluating at 2, f prime of 2 is 1/3, so the answer to this one is 2/3. Letter B is very similar. So it's f prime of x plus g prime of x, and we're evaluating now when x is 3. So f prime and g prime, 2 pi plus 5. 2 pi plus 5. So that one, those are pretty straightforward. Now it gets a little harder. Am I going too fast? Everybody good? Letter C, it's the product rule now, so it's first times the derivative of the second plus the second times the derivative of the first. We're at 3 now this time. They switched it up. We're at 3. F and g prime, that's 15. G and f prime, that's negative 8 pi. So negative 8 pi. So 15 minus 8 pi. Letter D, that's the quotient rule. Now bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared, g squared of x. So there's quotient rule. Got to get values g and f prime. Where are we at? At 2. G and f prime, 2/3. F and g prime, minus 24 over g squared, 4. Yeah, I'm at 2, yep. Ugh, yuck. Multiply everything by 3, that's what I would do. So 2 minus, 72 over 12? So 70 over 12, that's 35 over 6. I mean, yeah, I want you to get the value, but it's more, do you know how to take the derivative? We've got to get that part right first. Letter E, I've written before. I want you to give it a try. It should be, if you know it, it goes quick. If you don't know, it's going to be impossible. Did I mess it up? What do you got? Oh, was it negative? Oh, was it negative? Oh, okay. So minus. That should be a plus. What does that make that? 74 over 12, 37 over 6. Thank you. Thank you. Missed the negative sign. On letter E, what do you think the derivative is? Write it out. What do you think? I have written this before. Not today, but in the past. How would you take the derivative of a nested function? It's essentially the chain rule. Letter E is the chain rule. All right, ready for it? You either know it or you don't, kind of. Derivative of the outside, leave the inside alone. Derivative of the inside. That's the chain rule. There you go. Derivative of the outside, leave the inside alone. It comes with it. And then times the derivative of the inside. Well, now, let's see. F prime of, we're evaluating at 2. So g of 2 on the inside. G of 2 is 2. And g prime of 2 is negative 3. But we got one extra step here. I need f prime of 2. F prime of 2 is 1/3. So 1/3 times negative 3, negative 1 is the final answer on that one. Try f. What do you think f is? And this gets down to the process. We're not focused on a specific function. We're focused on what if we had the square root of the function? What would you do? How would you take the derivative? I think it'd be 1/2 f of x to the negative 1/2. That's the square root part. Because it's really to the 1/2 power. So we're going to multiply by 1/2, reduce the power by 1, that's negative 1/2. But then the chain rule says you got to multiply times the derivative of the inside. So I'd really need f prime of x over 2 square root of f of x. So there's the derivative right there. Of anything, any function, when you take the square root, it's going to follow that format. And we're going to evaluate it too. So f prime of 2 is 1/3 over 2 times square root of, let's see, what's f of 2? Of 8. Oh, great. I don't know, 1/3, 4 square root of 2, because 8 is square root of 2 over 2. So 1 over 12 square root of 2. Multiply top and bottom by 3. That's what I would have. I'd leave it like that. G. One over g squared, 1 over a function squared. Well, if it's 1 over, I would write it as g to the negative 2 of x. If that top is just a constant, if there's no variables or no functions in the numerator, I'll just bring that denominator up to the top, make it a negative power. So it's negative 2 g of x, to the negative 3 now. G to the negative 3 of x, and then times g prime of x, times the derivative of the inside. So this is negative 2 g prime of x over g to the 3rd. Now we just need some values, right? G prime, where are we at? 3. G prime of 3 is 5. Negative 2 times 5 over g to the 3rd, negative 64. So 10 over 64, 5 over 32. And then they really hit you with a rough one on h. Let's try h. Well, first of all, we talked about what we need to do when we have a square root of a function. So the first part is 1/2 f squared of x plus g squared of x. to the negative 1/2. So anytime you have a function, a square root of a function, we're going to start out that way. It's got to be the 1/2 and the negative 1/2. But now we're going to multiply times the derivative of the inside. And that's the outside function is squared. So we have 2f of x. We're going to reduce the power by 1, multiply by 2, reduce the power by 1, but then times the derivative of the inside. That's the chain rule. So that's the piece that's easy to forget. I mean, we took care of the squared, but now we need to get the derivative of the inside. Plus 2g of x, g prime of x. And this, of course, ends up being a mile long. The second piece stays on top. So 2f of x, f prime of x, 2g of x, g prime of x, all over. Oh, where did I get the 2? Oh, yeah, they each have a 2. This is 2 times square root of f squared of x plus g squared of x. That's really what it ends up being. And let's quickly throw some values in here and we'll call it good. So 2 times, I need f and f prime. F and f prime, 8/3. Plus g and g prime, -6. Oh, and I need the 2 there. Almost forgot that. 2 square root of f squared, so 64 plus 9. 64 plus 9. (16/3 minus 12) over 2 squared is 73. Well, let's multiply everything by 3. Multiply the top by 3, multiply the bottom by 3, and we get 16 minus 36 over 6 squared is 73. So negative 20 over 6 squared is 73. I'm getting negative 10 over 3 squared is 73. And the question is, well, do we have to rationalize? The only time you really have to rationalize is if you have a multiple choice question or you want to check the back of the book. And the back of the book has it rationalized. Woo, doozy. Questions on that one? Yeah, I mean, you might have questions when you actually have to do it. So on number 39, if you got problems, come in and see me. All right, next. This is gateway stuff. Here, go do it. As a team, as a pair. Go get them. You guys do it. He's got it. He's got this. There you go. Give him a nice round of applause. Yeah. Good job. Make it into a negative power. Multiply. Just use power rule, but don't end it with a negative power. Didn't start with a negative power. Don't end it with a negative power. All right. How about the one off to the right? Who wants it? All three of you going to go up? All right. We talked about a square root of a function, what you would do first if you had the square root of a function. I'm recording this. If you're watching this at home, you'll have to do a little fast forwarding. Yeah, I agree with that. Give him a nice round of applause. So the square root is 1/2 the function to the negative 1/2. That's the outside. Derivative of the inside is just 15x squared. And so we set that down to the denominator. Very good. Oh, okay. Who's my next? I'm going to go with you guys over here. This is a rough one. You guys take the next one to the left there. Yeah.
If you do the derivative, you have to do times 3.
That's right.
Okay, so
that's
this
correct.
is right then?
You lost your plus.
Well, yeah, I have it.
Oh, I see. Yep. Looks good so far.
No, minus.
Yeah, because it's negative, isn't it? Yep. And you could write that. I'll give you a little hint. You can write that as cosine squared of 3x. All right. Look at that. If you get this one right, I'll tell you what. Oh, who said that? You could reduce that more? What's the answer?
I can't remember.
Okay. Right. It's really cosine of, I'll show this again. I'm not going to show this 100 times, but I'll show it again. Unless you ask me, then I have no problem showing it. So that's all we have, but this is what is sitting right here, kind of. It's kind of sitting there. That's the double angle formula for cosine. We just need to plug a 3x in for x. This is a plugging 3x in for x. Well, if I plug 3x in for x, that's where we get that 6x. So this is the full credit answer right there. So up until that point, you had a 1 out of 2. Now you have a 2 out of 2. You got it? Because it's easy? All three of you go. Catch any mistakes he makes. This is your gateway, by the way. All I do is change the numbers. They got it? Nice round of applause. Good job. Oh, the next one is a little tricky. We're running out of tables, though. Who wants it? Not a whole lot left. Do you think he does? Here, go take it. You two go take it. Do you want a hint? It's a very small hint. It's not a very good hint. I showed a little trick to this. If you feel like you got it, go ahead. Okay, stop for a second. Do you guys want him to continue in this manner, or does anyone have any suggestions? Okay, go ahead. Keep going. No, I think you're doing great. No, you're good. You're done. Just turn into a radical now. There you go. Nice round of applause. This is 5x to the 6 halves times x to the 1 half. That's where you get 7 halves. If you want to do the product rule on that, go ahead, knock yourself out. But I would bet you're not going to come up with that answer doing the product rule. With that being said, I have had students get that answer doing the product rule. You can. But boy, it's a journey you don't want to be on. It really is. You went up with them, didn't you? Yeah, okay, all right. Only 2 groups left. You guys want? Here, you guys take this one. This one's not too bad. Go ahead. And we're going to help you. Nice job, you guys. Very good. Very good. All right, I think we're, what time? Let's see, we got TA today, 11, what period is this? Second? Oh, yeah, we got all the time in the world. Okay. Last group. Did you guys go yet? I didn't think so.
Yeah.
This is an easy one. Oh, yeah, that's right.
I had to make sure everybody out there.
Sarah's hiding over here.
That's not right. I didn't write it. You write it. You're the one that wants to write it wrong. You're the one. Okay, if it's wrong, it's wrong. What do we have? It's not right. I just don't know where to take it. What? Is this right?
That's not right. There's no way.
What's the derivative of tangent?
Oh, that's cotangent. Sorry. I was thinking it was cotangent. Okay, shut up. You followed me.
It looks right other than that. Derivative of tangent, secant squared. You got to keep pressure down the whole time. Good job. You guys got an easy one. This one's not bad at all. There you go. You guys are going to nail this. You guys got it. Don't put your hand on it. Erase this cosine. There's the eraser. Okay. So if we're going to take the derivative of that, it'd be first times derivative of second. This is a product rule.
It's product rule.
Product
Okay.
rule. That's product rule. So I like your beginning is okay. And it's okay to go second times derivative of the first. Now you just need plus, and make sure you just take the derivative of the other one now. There you go. Now, what can we take out? Just an x, right? I think just an x. Yeah, nice round of applause. Yeah. All right, see if we can get this last one. dy dx, bottom times the derivative of the top. All right, I'm not done. I'm going to pause here. That's bottom times the derivative of the top, but with the chain rule built in there because it's tangent of x third. So derivative of tangent is secant squared. Derivative of x to the third is 3x squared minus the top times the derivative of the bottom times 12x squared. All over 16x to the sixth. Let's see what we can take out. Looks like we have x to the fifth on the first one, but only an x squared on the other one. We can take out a 12x squared. 4 times 3, that's going to be the 12. X secant squared of x to the third minus tangent of x to the third over 16x to the sixth. Right, we can take out a 12x squared. Oh, wait. I think I messed that up. This should be, I only took out the x squared. This should be an x to the third. No, that's not the bad part. This should be x to the third. There we go. Twelve six is 3/4, so 3 x to the third, secant squared, x to the third. Over 4x to the fourth.